Hope all of us are doing fine. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. In this particular discussion, I'm going to look at a specific example which I had promised, and this is going to entail finding different quartiles for the deciles, percentiles, and of course the quartiles. And this is going to constitute a general discussion for the various sets of these particular averages that we have listed under the concept of quantiles. Now, in my right side of the board, I've given a frequency distribution, and of course, which constitute this specific set of classes together with the frequency. And this is going to be the frequency, cumulative frequency less than type, which I've given in my last column. Now, this specific data is going to assist us evaluate various sets of quartiles, quantiles, and percentiles, perhaps in that specific order. Now, in this case, for us to find a particular set of specifically, we can start with the quartiles. We have said that we can find the ith quartile by using this specific formula, whereby we say that the ith quartile is represented using the formula of qi given as the lower class boundary of the quartile class plus the class size given in terms of w all over the frequency of the quartile class, and this is going to be multiplied with a specific number of observations divided by 4 minus the cumulative frequency of the class preceding the quartile class given as C. So in this case, it's then therefore going to be important for us to identify the various aspects of this lower class boundary, of course, which we have been given, and of course the class size and the frequency and the number of observations, of course, and the cumulative frequency preceding the quartile class. And in this case, our n is going to be given in terms of the total number of the cumulative frequency given in terms of 493. And of course, we're going to identify the quartile class from this specific set of data. And as we said, the quartile class is going to be given in terms of qi is equivalent to in all over 4. And this is going to be a value of the cumulative frequency equal to or greater than this specific value that we're going to obtain. So this is equivalent to the ith quartile. So in case we are going to find the first quartile, then therefore we're going to have this letter for I represented as such. So we had mentioned earlier in our discussion that I is going to have a range of values between 1, 2, and 3, representing the first, second, and third quartile in that particular order. So we're going to have this one as the first quartile times the number of observations, which is basically 493. They constitute the cumulative frequency of this specific sort of data, and this is going to be divided by 4. So therefore, for the first quartile, we're going to obtain this one as Q1, and that is going to give us the value of 123. This is going to be 25. And therefore, for us to find this class whereby this first quartile, the class that contains the first quartile, the cumulative frequency is going to be equivalent to or greater than this specific value. And therefore, we're going to consider the cumulative frequency whereby, so this cumulative frequency is less than this value. And therefore, it's going to be constituting a value ranging this specific value of 160. And therefore, this is going to be a class that is going to contain the first quartile class given as such. And of course, we're going to see then, therefore, that we can find the values of LQ1, which is the cumulative frequency or the lower class boundary of the cumulative frequency of that specific quartile class. And this is going to be a value of 170, which is a lower class limit of the class boundary of this specific class. So we had said that we can basically find the lower class boundary of this specific quartile class by having this lower class boundary minus the value of u divided by 2. But in this case, the difference or the units of measurement is 170 minus 170, which is going to form the value of the units of measurement to be 0. And therefore, we're going to have 170 as our specific lower class boundary for this particular class. And therefore, we're going to have this one LQI represented as 170. For the class, we did basically said that this is going to be the ratio between R over K, whereby R is the range, particularly forming the difference between these extreme values of the first, the lower class limit of the first class and the upper class limit of the last class. And this is going to be basically a value of so there's a correction here. We're going to have this one as 250 and not 450 given as such. So this is going to be the difference between 250, which is a range, minus 140 divided by the number of classes, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is going to be 110 divided by 11, and this is going to give us the value of a W representing a 10, and therefore the class size is going to be a value given as a W equivalent to 10 given as such. And then we shall have the frequency of the of course a first quartile class, which is going to be as a value of 72. And then we shall have another value of the cumulative frequency of the frequency preceding the first quartile, which is going to be 8. And therefore, for us to find the first quartile, we shall do a substitution of these particular values. Now, because of space, we shall have to, of course, substitute these values in this formula. So we shall have this lower class boundary of the first quartile class given as 170. And then the class size, we have said is going to be a value of 10. The cumulative frequency of the first quartile class is 72. And then the value of IN over 4, we have found it as 123.25. So we shall have 123.25, and then minus the value of the cumulative frequency of the class preceding the quartile class given as such. So this is going to be the value of Q1, which is the first quartile, and it's going to give us the value of 174.90 given as such. And this is going to be the procedure that we're going to use in finding the various quartiles from a specific set of data given from the above. So in this case, we're going to just use the same procedure as I've said to find the second and the third quartile in that particular case. Now, in this specific respect as well, I'm going to look at the concept of the quantile. And as I had said, of course, we are going to use a specific formula in trying to determine a specific set of particularly not the quantile, but we're going to use a specific formula in trying to find the decile, which is of course a distribution that's going to be dividing a particular kind of data in 10 equal parts. And this of course is going to be assisting us in trying to find various sets of deciles from a particular set of data like the one that I got above. Therefore, we can just use the specific procedure that we had, of course, listed for finding the concept of deciles. And I'm going to use one of the examples of finding a particular decile from this specific set of group data. So we are going to have this specific illustration for the deciles. And as I said, we can find the ith decile by using this general representation of the lower class boundary of the decile class given as such. And of course, we're going to have that one added to the class size over the frequency of the decile class given in terms of FDI. And then we're going to have this one multiplied by the value of IN all over 10 minus the cumulative frequency less than type of the class preceding the ith decile class. So in this case, if we are required to find the 7th decile, then we're going to have this one represented as the decile class. So therefore, we're going to have this one as 7 times this specific number divided by 10. And as I said, the value of n is going to constitute the total cumulative frequency, which is going to be, of course, 493 divided by 10. So this is going to give us the value of, basically the value of, just to do an evaluation of that. So this is going to give us the value of 345.1. And that's going to form our cumulative frequency, which is equivalent to or greater than the value of that specific decile class. So we're going to have this one identified from this set of group data, and therefore it's going to fall under this specific frequency, and therefore our 7th decile is going to be falling under that class. So therefore we have identified this specific class. So the lower class boundary of this particular class, which is LDI of the 7th decile, is going to be 190, and then therefore we are going to have the class with it represented as well. So we have found already this one to be a value of 10, and then we shall have the cumulative frequency of the decile class, the 70 decile class given as 107, and we shall have of course this specific cumulative frequency of less than type of the class preceding the decile class given in terms of 244. So basically we shall do as well a substitution for this in trying to find our 70 at the decile in this particular case. So we shall have this one given in terms of D7 is equivalent to 190 plus the class size is 10 divided by the frequency of the 70 decile given as 107, and then we shall have that one multiplied by these specific values that we have. So we have evaluated this specific value of n over 10, and it has given us 345.1, and then this one minus the cumulative frequency of the frequency preceding the decile, the 70 decile, which is 244. So this, all of this is going to give us the 70 decile, of course, which is equivalent to 199.45, and that's going to be our 7th decile obtained from that specific class. So lastly, we're going to look at also the concept of finding a percentile using the general formula which we have discussed in this specific or our previous video on the concept of the percentiles. So generally for this one, I can give it in terms of a formula, so which we had mentioned for finding a specific percentile given as. So in this case, we're going to look at the 90th percentile, which basically we can give in terms of this. So this is equivalent to the lower class boundary of the, of course, 90th percentile given as P90, and then we're going to have the class size given as such, and then we shall have the frequency of the 90th percentile, and then we shall have I, which is of course going to be 90 times n all over 100, and then we shall have, so this one I've done a direct substitution so that these are the remaining, of course, values we're going to obtain. So we shall have this one given in terms of P10 is equivalent to, so let's identify these specific values for the lower class boundary of the 90th percentile, and then we shall have this one. So I said from our opening statement that we're going to find the P90 given as 90 times 493 divided by 100 given as such, and this is going to give us the value of 443.7 as our value for the frequency, cumulative frequency of the 90th percentile. And if we're going to look at this, and therefore it's going to fall under that specific class. So we shall have the lower class boundary of this 90th percentile as 220 given as such. So our value for this specific LP90 is equivalent to 220, and then we shall have W represented by 10, and the frequency of the 90th percentile class given in terms of that 1, and then we shall have the cumulative frequency of the frequency preceding this specific class as 434, which is this specific frequency given as such. So we shall do an evaluation by doing a direct substitution in this, by having this one represented in terms of 220, the class width is 10, the frequency of the 90th percentile is given as 31, and then we are going to have this specific product, which is this one given as 443.7. So we shall have this one as 443.7, and the cumulative frequency of the frequency preceding the 90th percentile given as 434 given as such. So the whole of this is going to give us a value, which of course is going to be 223.13 as our 90th percentile. So this is the procedure that we're going to use in trying to evaluate subsequent percentiles. And of course, that's going to form our last bit of this specific discussion on the concept of quantiles. So check our description boxes for various links, and also check our description boxes for similar videos on the concept of statistics. And kindly engage us in the comment section and subscribe to our channel so that we can be getting updates on various topics that we do in math and sciences. So that is it for now, guys. By God, please. We'll catch us in our next video.